All right, ladies and gentlemen, there is a lot of preview to deal with here. So I'm not going to mess around. I'm going to get down to it. Some places I'll show some work. Some places I won't show as much. But if you run into questions, we can deal with them in class. So here we go. Simplify each expression completely. First things first. The only multiplying going on here is the distributing going on with this stuff. So here, I don't think there's a whole lot of need for a lot of discussion here. Make sure with the 5 that minus is going with. Negative times negative is positive. And now we're just looking for like terms. And again, no more multiplying at this point. We're just getting those together. Negative 88 minus 10. Waha. You know what I'm going to say. Don't just square both terms. Either separate and FOIL it out if you are a more visual person, or you can do the pattern, which again is squaring your first term, the 5 and the x, multiplying these two together. So 5x times 3y is 15xy, and double it, 30xy. Square your last term. You will get the same thing whether you follow the pattern I just did or you FOIL over here. Just don't lose any variables. It's kind of important. Now the cube, that gets a little more interesting. So if you're going to spread it out, I'm not saying it's a terrible idea. I'm just reminding you, if you go that route, do a pair at a time, FOIL that out, and then take that answer and do it again with this one. Okay? Otherwise, what your option is going to be, but if you're going with the pattern way, which is the faster way, again, here's what we're going to do. We're going to, well, I'll actually write it out this way first. We're going to cube our first term, plus 3 times our first term squared times our second term, plus 3 times our first term times our second term squared, plus our last term squared. Excuse me, cubed. Wrote cubed, said squared. So remember with these, first term cubed, squared to the first, and then it's gone. Second term, our 7, not here, 1, 2, 3. If you can remember that pattern, that will go faster than all of the foiling, but if you are not confident with that, 12 and 7 is 84. You can always run it back this way. 98, 294x plus 343. Otherwise, again, the double, the FOIL, and then multiplying it again absolutely works. Okay, here, find f of 4. That just means substitute 4 in. Negative 4, excuse me. So again, that whole thing, I'm assuming most of you are going to be like, Hardy, I'm not dealing with that in pieces. I'm just going to get her done. And that is what we are going to do. You even could, if you wanted to, just a quick heads up. I'm always looking for ways to kind of simplify things. Here's the other thing you could do. You could go ahead and type this into your calculator like this, pull the chart, and go to -4. The same thing happens. So just saying, you have options. All right, find the value. C of n to the third. Replace x with n to the third. Everything else stays the same, and do not leave your answer that way. Multiply that out. You're not squaring the -5, just the n to the third. You're done. Now, here's a composition. Step 1. Find d of 2. Okay. So 7 times 2 minus 3 is 11. Then take that answer, not 2 again. Take that answer, 11, and plug it back into C. So let's see. -5 times 121. -605 plus 1, -604. Composition. Okay. This next one, not quite a composition, but we're going to plug 3a into my C function. So here's my C. So -5 times -9, -5 times 9 is -45a squared plus 1. But now you're going to multiply that times 5. And get that done. Okay, so 3a into C, and then times by 5. There's no more places to substitute into. And speaking of, here, we're just using the graphs. Make sure you're using the right graph. So f of -2, nope, open hole, that is not the answer, that is. So 3, g of 4, not the open hole, this one, -1 is 2. Now here we have pieces. F of 1 is 3. So this is going to be 4 times 3. G of -1, it's right there, it's +1. 12 minus 5 is 7. Now we get a composition. So G of 2 first is -3. So now I'm going to plug -3 into F and get 2 in pieces. Okay. Be cautious on the domain and range. Again, I'm looking for arrows. I see an arrow going left, so I'm like, okay. But there is no arrow going to the right. This point right here is as far as I'm going to go to the right. So I actually have an endpoint for my domain. My range, same danger. I see this going up forever. Both of these arrows do, so that's positive infinity. But I don't see an arrow going down forever. This is my lowest point, and I just follow it back to the axis and work it that way. This is going to be one of those tests. Even though it's in 2 pieces, you got to know your stuff and keep rolling. And I tried to help on the review with this one. I don't know if I'm going to be this nice in the test. Probably not. Here's f of x and g of x. Write a simplified function. Note that x is a label. Don't multiply your answer by it, because that's going to mess things up. So all I'm asking you on number 13 is to take f of x plus g of x. So 4x squared plus 2x minus 3 plus x plus 1. And just combine like terms. Nothing fancy or anything like that to deal with. Just watch your signs, get your answer. Don't put an x back on anything. Just leave it alone. These two are different. This is multiply, this is a composition. So multiply, this might take a minute. Whoops, minus 3. Totally your call on how you're going to work this. I think I'm just going to like distribute. So I'm going to distribute my x through first. And then I'm going to distribute my 1 through, which really does nothing. So let's see here. Just be careful with your, your degrees. So I've got a 4x to the third, 6x squared, minus 1x, or just minus x, minus 3. Good to go. But the composition, okay, g of x is right here. So this wants me to plug, well, I should put it this way, plug g of x into f. In other words, plug x plus 1 into that. And no, you cannot just leave it in this form. I must say this again. This is not x squared plus 1. Either FOIL it out and write it out or know your pattern. First, multiply them together and double. It's 1. I'm going to go ahead and distribute the next part, though. So once I distribute, and again, the nice thing about a video, you're like, Hardy, you are going way too fast with your writing. Well, just pause me until you're where I'm at. And it's going to be fairly easy, at least I hope, to follow the rest. Okay. Now, one thing I haven't mentioned yet, because I haven't had a need to, there can be domain restrictions on these functions, but remember, the only options that would be for is if you have a radical, it has to be greater than 0, and if you have a fraction, the denominator can't equal 0. So this time, after I avoid the temptation to try and cancel those x's, don't do it. That's as far as you can go. You have to make sure your denominator does not equal 0. So you've got to let me know that x can't be negative 1 in some way. You can give me all reals, you can give me x, you can give me interval notation, whatever you would like. Okay, next one with this. What is f minus g of 5? This is not a composition. There's no 0 there. I want you to find f when you plug 5 in, and I want you to find g when you plug 5 in, and I want you to subtract the answers. So f of 5. So 5 squared is 25, times 3 is 75, minus 5, which is 70. Here we got 5 minus 7, which is negative 2, and 70 minus negative 2 would be 72. So more just kind of substitution things. P times Q, same as what we did up here. Plug 8 into each of these, multiply the answers together. 8 minus 4 is 4. Absolute value of 4 times 2 is 8. 7 minus 8 is negative 1. Multiply the answers. But open circle is a composition. So step 1, we're going to plug negative 4 into here. That is absolute value. That is not just a set of parentheses. So this is 2 times positive 8, or 16. And then we're going to plug that answer into Q and get my final solution. Inverses. Find the inverse and state the inverse is a function. All right, inverse. We are just flipping all of these points. The x's and y's are all getting swapped. Now, remember, find the inverse and state if the inverse is a function. What you're looking for here. So you remember back when we were stating before, if a function was actually a function or not, we'd look at the x values and see if they repeated. Now when we're looking for the inverse, we're checking out to see if the y values repeat once we've done the inversion. So I look and I'm like, why, are any of those the same? No, so it's the inverse of function. Yes. If any of those y's would have repeated in my inverse, the answer would have been no. All right, let f of x equal this. Find the inverse. F of x is just y equals. Swap the x and y. We're solving for y, people. So now do I want to do it that way? No, I'm going to get rid of the fraction first. I could have minus the 4 first, but I'm just going to get rid of the fraction. So I'm going to multiply everything by 3 because I don't like dealing with the fractions. Here, the 3 cancels. Don't multiply the 2 by 3. But do remember to also do it to the 12. Now this is going to be a little more straightforward. Add my 12 over. Divide both sides by 2. And when we square root, remember you've got to have your plus minus in there. Because if we don't, we're only going to get half the graph, and we don't want half the graph. We need the whole thing. It's just something to keep in mind. All right, find the inverse of the function, graph both the function and the inverse. Well, I'm going to graph this right away. 2, 3, 4, 2, 3, 4. Now, so there's my original. Find the inverse. Switch x and y. Solve for y. And on this one, since I'm graphing it, I'm not just going to leave it as one big fraction. Ugh. It's kind of yucky. Again, when I make my lines, that line y equals x, do you have to draw this? No, but it kind of lets you see the reflections that you're getting from some of your points as you're doing this. So just something to keep an eye on. Okay, graph 2 examples of functions whose inverses are also functions that pass the horizontal line test. That would be the explanation, pass horizontal line test. So again, I mean, I'm just making up stuff as I go. I can go through the middle, that would work. I go through that, I could go through the middle. Only goes through one point. If this parabola was this way and I went horizontal, that would not work. I would have to be a little more cautious. All right. Show f of g of x and g of f of x. Let's do this. F of g of x. So we're going to plug this into that. Negative 1/3, negative 3x plus 9 plus 3. 3 times 1/3 is 1, so that'd just be x minus 3 plus 3 is x. That's what we want. G of f of x. So we're plugging this in for x right there. So negative times negative is x. Oops, I almost forgot the plus 9. See, that would have been bad. I need the whole equation. Negative 9 plus 9. Yes, they are. They both got me x. If either of those would not have gotten me x for a solution, the answer would be no, whether it was the first one or the second one. All right. The polynomial expression 8x cubed minus 125 is the expanded form of which of the following? Well, I can tell you right now, it's not a or c because there's a minus in the middle. And I can tell you it's not d because they're not both minus. When you're doing a difference of cubes, those two signs always have to be different. So just a little FYI. Factor completely. What do we got in common? We got x squared. What do we got in common over here? Hardy, we don't have anything in common. Well, we got to get something. Well, fine, I'll take a 1. Negative 1. 2x plus 3. Oh, I see it coming. I see it coming. Hardy's trying to pull a fast one on you. Hardy, we're done. Circle it and go to 27. No, that's a difference of squares. Well, what if I don't do that part? It's going to be minus a point if you did that on the test. So try to keep going. Keep working it out, making it go well. I think this is going to be the last one I do in this first part of the video. I think that puts me almost right at, pretty close to the midpoint here. The next one might be a little longer, but That's okay. We're going to treat it like it's a quadratic. Because if I did this one, there'd be my answer. The only difference now is 1 plus 1 is 2. So instead, 2 plus 2 is 4. Oh my gosh, I did it again. Difference is squares. First one's not. Second one is x at 3, x plus 3, x minus 3. Am I going to press on? I think I am. I'm going to try to make it to 30. Let's see how this goes. All right, anything in common? Yes, x. No, there's more. Oh, 5x. Oh, how not nice. Difference of squares again. I'm trying to get the idea across here to some of you. You've got to know these patterns. First plus second, first minus second. If you don't know your patterns, go back into your notes and work them. Here, treat it like squareds. For x squared plus minus, because it's a difference of squares, 7y squared. Hardy, can I keep breaking that down? Is 7 a perfect square? No. Okay, well then you know you can't. All right, last one. I can say I made it to 30 and feel happy with myself. All right. It's another difference of squares type problem. But the difference here is going to be, now there's an equal 0 sitting there. So you've got to set each of these equal to 0. And you can get some funky stuff. I ain't going to tell you you can't. Oh dear, I wrote a little too big and I'm not even going to fit this. Oh my gosh, not square root of 3, Hardy. Oh, am I going to be that mean? Oh my gosh, I was. Holy cow, man. What was I doing? What was I doing? Making it have a radical in the denominator. Feel free to holler at me. That was obnoxious. So Hardy, you felt so bad about it, you're going to make us do it twice. Yeah, well, sometimes even I can get myself into a little bit of, oh my gosh, and that's a -9. I should have pulled out an I. Some of you are probably screaming at the screen, Hardy, there's an I in there. There is. There is. This one doesn't have an I. Okay. All right. Wrap on half one. Part 2 will be coming shortly. We'll see you then.